Hello students, welcome to Prime Educare, a complete institute for JEE and NEET. So students, we have gone through the various concept of units. We have gone through the concept of measurements, like how can we measure the various physical quantities. Similarly, we have gone through the concept of dimension as well as the what is accuracy and precision. So now in this class we will proceed further. So what we will understand in today's class, we will go through the concept of errors and we will go through the concept of errors. So students, what is error basically? So in physics, as in actually in particularly in science, whatever experiment we are doing, whatever inventions are taking place, we have to take a measure of various values. We have to measure the various values of a substance. For example, if we have to measure the length, let's consider a length of a wire. If in a lab, you have seen the lab of physics and chemistry in your school. So we have the various types of instruments in it. We have a wire, we have a resistors, we have various types of instruments. So let's consider a wire is there. So a wire is there, a conducting wire. So let's consider we have a conducting wire, and in this conducting wire we have a particular length. We are measuring this length of this particular wire. So we are measuring the length of this particular wire. So the length of this particular wire, it cannot be accurate on the first time, because there can be a many types of situation of cases of errors can be there. So what the experiments do, what in the lab scientists do, they take various values. They take n number of values to measure it. So they take n number of values to measure the length of this wire. So to measure the length of this wire, n number of values are taken. So for example, we have the value length L1, then L2, L3, and let's consider till L5. So we have the various values of the length of this wire. So for the value of this length of the wire, we have taken the various values to measure its length. So now what we can do in the lab, now these values are taken and we find the true value. So students, what is basically the true value is? True value is the average of all these values. So what is true value is? True value is the average of all these values. So average is L1 plus L2 till L5 divided by 5. So this is the true value. So now let's consider this true value comes out to be equal to L dash. So this true value comes out to be L dash. So when we have taken the first value, that is L1, and here it is L dash. So we have taken the true value L dash and we have already found the value L1. So there can be the case that there can be the difference between L1 and L dash. Let's consider the L1 is 2.1. So let's consider L1 is 2.1 and this L dash is 2.2 centimeter. So we can see that there is certain difference between the true value and the calculated value. So this L1 is the calculated value and this L dash is the true value, which comes out to be the average of all the experimental values taken. So there is a certain difference between them. This is L1, this is L dash. So there is a certain difference between them. So that is called the error. So what is error? Error is L dash minus L. So this is the error. This is the true value and this is minus L. So this is what we call the error. Error is the difference between the true value and the calculated value. Like what is actually the value of the length of the wire and what it is coming out through the experiment. We have done the experiment, we have set up the instruments. Now what the value is coming out to be? What is the value that is coming out? That is the calculated value. So calculated value minus the true value, expected actual value is the, what do we call as the error. So error is uncertainty in measurement of a physical quantity. That is called the error in this errors. So now when we talk further, so basically in the classification of errors, we have three types of errors. So what are the three types of errors, students? We have the systematic error, we have the random errors, and we have the gross errors. So when we are classifying these errors, so what the scientists place into the three categories. So what are all the three categories? We have the systematic error. So in the three categories, we have the systematic errors. We have, this is the systematic errors. Then we have the random errors. So we have the systematic errors. We have the random errors. And then comes the value of, we have the random errors and then gross error. So this is how the classification of errors has been done. We have systematic, random and gross error. So this is how the classification of errors has been done. We have three types of errors: systematic, random and gross. So now we will learn about this in detail. What are these types of errors in? So basically students, let's talk about the systematic error. So what is systematic error? Let's consider we have a length of a wire. So we have a length of a wire considered. So length of a wire is considered as L dash, which is equal to, let's consider the value as L dash as, so what is L dash is? So what is L dash is? Let's consider the length of a wire. So L dash is 4.1 centimeter. So this is the length of the wire, which is equal to 4.1 centimeter. So we have a wire whose length is coming out to be 4.1 centimeter. So now students, let's consider this is the actual length of the wire, which is equal to 4.1 centimeter. But now what happened when we are measuring it? The measuring value are coming out to be, let's consider 4.15. Let's consider the another sample has been taken and let's consider the value coming out to be 4.20. Then another sample done and let's consider values is coming out to be 4.25. Another sample is coming, let's consider the value is coming out to be 4.28 centimeter. So these are the values which are coming out. So when we are doing the experiment, we have taken the first the length value 4.1, but when we have done the experiment, so through the experiment the values are coming out to be 4.15 centimeter, 4.2 centimeter, 4.25 centimeter, 4.28 centimeter. So these are the values that are coming out. Now if we see what all these values have in common. So if we analyze these values, what all these values have in common? If you can relate, all these values errors is in positive. So what is the error here? Error is 4.15 minus 4.1, which is equal to 0.05 centimeter. So the error is 0.05 centimeter. Then what is the error here? It is 4.2 minus 4.1. So 4.2 minus 4.1. So 4.2 minus 4.1, which is equal to 0.1 centimeter. So this is 4.2 minus 4.1, which is 0.1 centimeter. Similarly 4.25 minus 4. So here if we find out, so this value, okay, so this value is 0.1 minus, this is 0.05 centimeter. This is 4.2 centimeter minus 4.1, which is equal to 0.1 centimeter. Then this is equal to 4.15. So 4.15 minus 4.1, which is equal to 0.1. 4.15 centimeter, let's suppose error is coming out to be, then 4.28 minus 4.1, which is equal to 4.14 centimeter. So here the error is coming out to be 0.14 centimeter. So this is 4.15 minus 4 point, so this is 0.05 actually mein. So this is 0.405 centimeter. So here if we understand the errors which are coming out to be, this is 4.1, this is 4.15, 4.2, 4.1. So here in this we can see that the errors are coming out to be in positive. All the values, all the expected values are greater. All the expected values, all the calculated values are greater than the true value. So they are all coming in the positive direction. They are all in the positive. So the errors are what we call as a systematic, because they are all in the positive direction. If they would have been lesser, we call it in the negative errors. So in the systematic errors, the errors which are coming are defined, that why are they coming, that what is the reason behind the errors that is coming. We already know those types of errors. So why, so we will study in detail like why are these errors coming. So we have various several types of reasons like why is this error coming. So if we look further, this error is coming. So first we have the zero error. So students, what is basically the zero error? Let's suppose, what is a zero error? We always start measuring the value from, consider from a zero value. We already start measuring the value from 0. This is 1 centimeter, then this is 2 centimeter. So we always take the value from 0. We always consider the value from 0. So this is from where we consider the value from, we always consider the value from 0. But by chance, due to the overuse of the setup, overuse of this instrument, this 0 has been shifted. Let's say we have various readings in this least count. So this 0 has been shifted to two other, increased to two more readings. So this 0 has been increased to plus 2. So now the value will come out from here. So if we are measuring the length, so previously let's consider the length of a wire we are measuring. So previously let's consider the length of a wire when there was no zero error. So when there was no zero error, the length of wire, let's consider it was 2 centimeter. So length of the wire, let's consider it was 2 centimeter. So previously when we were reading from the 0, when we were reading, when the instrument was new, there was no error in it. So we were reading from the value 0. So the value was coming out to be 2 centimeter. But now if the 0, through the overuse of the instrument, if this 0 is shifted by two values, if this 0 is shifted by two values to the upper, so this 0 count will be shifted, and now the this length of the wire will be equal to 2.2. This would be the reading. So this is called the zero error, which is coming out to because of the error in the 0. Zero error, this zero error has been shifted upwards or downwards. It can be the reason that zero error has been shifted 4 readings downward or 4 readings upward, due to which this error is coming. So this is what do we call, students, the zero error. Now if we talk further, so what is then comes the another cause. What is the another cause of the systematic error? So we have the first cause of the systematic error was zero error. Now the another cause is the environmental factor. Let's say we are performing an experiment, and if the temperature of the surrounding is changing, if the temperature of surrounding is increasing or decreasing, temperature of surrounding is increasing or decreasing, then we say it is due to the environmental error. So there can be the reason due to temperature, humidity of the substance, like why, what humidity has been changed. So the error which is coming due to the environmental factors, due to the factors related to the environment, temperature, humidity. So that leads to what? Environmental error. Now we will talk further. So what is the next type of environment systematic error is the imperfection in the experimental technique or procedure. We are performing an experiment and there is a procedure to it. For example, we prepare a tea. We prepare a tea, so there is a procedure for it, that we have to pour water. We have to then pour, we have to also heat the gas stove. Then we have to pour water. We have to pour the milk. We have to put the tea samples in it. So, but if we don't own the oven, own the switch of the stove, then the tea will not be made. Similarly, if we are performing an experiment, if an experiment is performed, if we are performing an experiment, if the experiment is being performed, and if we are performing the experiment, and then while performing the experiment we are missing out certain techniques, if the certain techniques are missed out, if certain techniques are missed out, then what do we call it as? The imperfection technique experiment, due to the imperfection in the technique. So this certain techniques are missed out. If the certain techniques are missed out, then what do we call? That is called the imperfection in experimental technique or procedure. So that is called the imperfection in the experimental technique or procedure, that when we are performing an experiment and when we are missing out certain technique, that is. Now let's proceed further. Now personal error or observational error. So this value of the error is inversely proportional to the number of readings. If we do n number of readings, if we take n number of readings, then the error comes out to be lesser. So what if we have taken the 5 samples and 50 samples, then probability of error is lesser than when we have taken 50 samples. So when we have taken the larger number of samples, then there the probability is lesser. Then there the probability is lesser as compared to when the less number of samples are taken. For example, you can consider a situation like in a class, exam has been conducted, and if we have taken the only if we have to find the average of the students class, and there are all types of students, there are good students, there are bad students. So we have all type of students, they are good, there are bad students. So now if the average value, if we have taken only 5 samples, then it would not tell whether there are, if we have taken only the samples of the good students, then it will not give us the information that there are also the students which have not got good marks, which have not improved in the exam. So if we taken the larger sample, that those students would also have been included, then those students would also have been included. So the number of readings is inversely proportional to the error. So larger the readings, error is lesser. Now students, let's move further. So this was all about the systematic errors. So in systematic errors, we take the errors which are due to surroundings, due to the imperfection in the procedure, or due to the human error. Now random errors. So now students, what are the random errors? This is the second type of errors. These random errors are those errors which we do not know the reason behind it. There can be a certain change in the instrumental voltage, like if we are performing the Ohm's law. So if we are performing the Ohm's law, and the voltage of, we know that voltage is directly proportional to the current flowing, but the voltage randomly changes, in it, so it is just due to the voltage suddenly changes. So we don't know the reason behind it, like why the voltage suddenly changes. So that is called the random error. If we talk about the random and the systematic errors can be improved. They can be minimized. We know that was error in measuring, taking the zero value. So we can improve that zero value. Similarly, there is an error in performing, we missed out certain technique. So we can improve it. So in systematic error, we can improve the technique, improve it. We can minimize the error. But in the random errors, we cannot minimize it. Random errors cannot be minimized. We don't know the reason behind it, but the error is coming. We don't know it's going in positive or negative. We don't know the direction. So the errors are coming out. Now let's proceed further. So we had the different measurement of lengths of rod. Now we have to find the mean value, absolute, mean absolute. So we will study this. We will study this. Then we will solve the question numerical. So this is where we are going to study that concept of the question, and then we are going to come back here and then we are going to solve it. Okay, students. So now true value and error. So this true value I have already explained. Like when we are performing an experiment, we have taken a number of values such as A1, A2, A3, A4, A5. So we have calculated all these values. So what is the true value? True value is the average of this value. Average of this value is A1 plus A2 till A5 divided by 5. So this is the average value, which is called the true value. So this we will consider the length of that wire. So if a wire is given, so there are 5 types of measurements are given. So the mean value is the average value we will consider as the true value. Now students, what is the mean absolute error? So this was the true value. Then mean absolute error is that when we have taken the values, like experiment has been done, A1, if we have done the experiment, this is A1, A2. So we have done the experiment A1, A2, A3, A4, A5 and calculated the average value. This is coming out to be AN. Now we have to find like what is the average of the error. If we have to find what is the average of the error. So what is the average of the error? It is A1 minus AN here. It will be how is the error different from the actual value. So this is the actual value, this is the actual value, this is the average value. So how is this actual value different from the true value? So A1 minus AN, then A2 minus AN, then A3 minus AN, A4 minus AN, and then A5 minus AN. So we have all these are the values which are coming out. We have taken all these values. AN is the true value, average value. So A1 minus AN, A2 minus AN. So this comes out to be the error in the value. But if we add this, the sum comes out to be 0. So what we do? We take the absolute value. So what is the absolute value? We take the mod of it. So students, what is the mod of it? Mod of it is the positive value. So A1 minus AN, we take the positive value. Like if it is coming out to be minus 2.1, we take it as 2.1. So minus 2.1, we take it as 2.1. Like similarly, if it is coming out to be 2.2, it is coming out to be 2.2, positive 2.2. Similarly, here also it will come out to be 2.4. So we take all the positive values to calculate the mean absolute error. So this is how we find the mean absolute error. So what is absolute error? It is the difference between the mean and the average and the error value, experimental value. Now students, what is the relative error? Relative error of a measured quantity is the ratio of the mean absolute error to the mean value of that quantity. So we have find out the absolute error. So this is the absolute error we have calculated, and how is, what fraction it is from the mean value. How is it smaller or is it greater? So is it smaller or greater? So this will give us the relative error. So relative error is the change in the mean value to the mean value. So we will understand through a numerical. And percentage error is that when we have the relative error. So what is percentage error? When we have the relative error and when we multiply this relative error with a factor of 100. So when we multiply this relative error with a factor of 100, that gives us the percentage error. So I hope students till here you have got the concept. So let's understand this numerical. So when we have the different measurements of a length of a rod, so we have a rod and we were measuring its length. So a rod length is measured. So when we have L1 equal to 4.2 centimeter, then L2, then L3, then L4, and then L5. So what is L2, which is 4.5 centimeter, then L3 is 4.4 centimeter, then L4 is 4.3 centimeter, and then we have L5 which is 4.6. So now if we have to measure the mean value, we have to measure the mean value comes out to be the average of it. So we have to sum it. So mean value will gives us the, when we measure the value, we will measure L1 plus L2 plus L3 plus L4 plus L5 divided by 5. So this will give us the mean value. This will give us the average value. Like what is the average value of it? Then absolute error. Absolute error, here we can calculate the mean value. So absolute error is when we have to A bar minus L1, then A bar minus L2, then A bar minus L3 plus A bar minus L4 plus A bar minus L5. So this is how we can find the absolute error. So this is the absolute error. Mean absolute error will be when we will divide it by 5. So mean absolute error will be absolute error divided by 5. So mean absolute error is absolute error divide by 5. So when we will divide by 5, that will give the value of mean absolute error. And then fractional error, we can multiply, we have find the mean value, we have find the mean absolute error, so it can be fraction of it, and then we can multiply it with the 100, that will give us the percentage error. Okay students, so now we will go further. So now what is this is all about the concept of errors when we are performing an experiment. So when we are performing an experiment, this all gives us the concept of errors. Now when we have the concept of significant figures. So what is the concept of the significant figures? So students, basically what is a significant figure? A significant figure is the digits, are the digits in the number that are measured precisely. That, so for example, when we are measuring the length of a rod, if it is 2.4 centimeter, there are two experiments done, and we are measuring it. So one value is coming out to be 2.4 centimeter, and other value, let's consider, it is considered as 2.41 centimeter. So we have taken the two values, one is 2.4, another coming out to be 2.41 centimeter. So here we can see that one value is given to the first digit. So one value is given to the first digit, another value is given to us to the second digit. So here the another value is given to the second digit, here it is only given to the first digit. So 2.4, then but after 2.4 how much? 1. So here it is more precisely described. So here in this case it is described more precisely. So this is the significant figures. So if we have to find like what is the significant figure in a number, so 3.14, here the significant figures will be 3. So what are the rules for determining the number of significant figures? So for determining the number of significant figures, all the non-zero, first of all, when we have the all non-zero digits, when we have non-zero digits, then all the non-zero digits will be counted. For example, we have 4 2.3. So we have 4 2.3. So here in all the 3 digits will be counted, 4, 2 and 3. All 3 digits will be counted. 243.4. Here we have 4 digits. So all the 4 digits will be counted. Similarly 5.03, all the all the digits will be counted. And if we have 0, but basically when we are counting the number of significant digits, we have to consider the case of 0. We should know when is the 0 counted and when is 0 not counted. So when we have all non-zero will be counted. But if there is 1 0, if we have 1 0 here in the mid of the digits, if we have 1 0, in the mid of the digits if we have 1 0, then that will also be counted. So this is the first rule, this is the second rule. So in the first rule, all the non-zero digits will be counted. In the second rule, if the 0 is coming between the non-zero digits, it will also be counted again. Then leading zeros will not be counted. If we have the zeros in the initial, if initially we have the zeros like 0.543, 0.006, here we have the zeros at the initial level. So leading zeros are not counted. You just have to remember this rule. You just have to remember this rule, that the leading zeros, when we have the zeros at the leading places, when we have the zeros at the leading places, it will not be counted. But if we have the zeros after the digits, after the non-zero digits, that will be counted. For example, 4.330, here all the zeros will be counted. So here it will be 4 significant digits. But here 0.543, here the zeros are at the leading places, so it will not be counted. 1.32 into 10 to the power minus 2, here the zeros are at the trailing places afterwards, so it will not be 1.32 into 10 to the power minus 2. So here it is going in the initial level, so it will not be counted. So only the zeros which are coming in the initially leading values are not counted. So and also in this case, when we have written in this form order of magnitude in the exponential notation, when we have written in the exponential, this was in all the rule 1 to 4, if the zeros at the leading places, then it will not be counted, else it will be counted. If the zeros are at the leading places, it will not be counted, else it will be counted. And in the rest, if it is in the exponential notation, if it is in the exponential notation 10 to the power minus 2, 10 to the power 4, then also the significant figures are not counted. Then also significant figures are not counted. Like 1.32 significant figures are 3. 1.32 significant figures are 3, 10 to the power 4 will not be counted. Now students, rounding of numbers, how can we round off? Like when we do many experiments 3.21, if we do experiments 3.251, so we have done various experiments, and now if we have to give the value to two significance digits, if we have to give in the value to 2 digits, then we have to round it off. So that is called the principle of rounding. So if the rounding, if the after dot, if the number is lesser than 5, then it is not, we should know the rules, that if the number is lesser than 5, then the rounding digit, then it will not be included, plus 1 will not be done, it will remain the same, it will be 7.82, so it will be 7.8 only. 3.94, 4 is lesser than 5, it will be written as 3.9. But if the digit is more than 5, if we have the digit which is more than 5, like 6.87, so if the digit is more than 5, 6.87, so it will be, here we can note that 7 is greater than 5, here we can note that 7 is greater than 5, so it will be rounded off, so it will be equal to 6.9. Then we have 12.78. So here we can note in this number 12.78, this 8 number is greater than 5. This 8 is greater than 5. So this can be written as 12.8. So if the digit is to be dropped, if it to be dropped is 5 followed by digit other than 0, then the preceding digit is raised by 1. So if we see that 16.3.54, so here it is 5 is greater than 1, so it is rounded to 16.4. Similarly here also, if the digit to be dropped is, if we have the digit which is 5, like if in this case the digit was lesser than 5, in this case the digit was greater than 5. So if the digit is greater than, lesser than 5, it will be written simply. If the digit is greater than 5, it will be written including, in 1 will be included, raised by 5. If the digit is 5, then it will be also raised to, like 6.758, so 5 it is given, it is greater than 5 it is there, so it will be again be rounded to 6.8. So this is the rule for rounding. So this is the rule for rounding a numbers. How can the numbers be rounded off? So if the digit is to be dropped is 5 or 5 followed by 0, then the preceding digit is unchanged. Like if x is equal to 3.250, so it will remain 3.2. If the digit to be dropped is 5 or 5 followed by zeros, then 5, like 5 is followed by zeros, is raised by 1 if it is odd. So if it is odd number, like 7 is an odd number, so it will be written as 3.8. Similarly here also 5 is followed by 0, so 5 is followed by 0, so 1 is an odd number, so it will be included with it will be also raised by 1, which is 16.2. So this is all the concept of the errors of the rounding off. So what we have studied about the errors. We have gone through the various concepts of errors, like when we are doing the experiment, we have several types of errors in it, like we have the systematic error, we have the random error, we have the gross error. Now then we talked about the significant digits. What are significant digits? So which that are measured precisely. So how to count the number of digits, and when the significant digits are not counted, when we have the leading zeros. When we have the leading zeros, then the number of zeros will not be counted in the number of significant digits. And when we have the digits in the exponential, then it is not counted. Then we took of the rounding of numbers, where we also see the several types of properties in it. For example, when we have to the for if the number is greater than 5, then it will be plus 1 raised to 1. If it is less than 5, it will remain same. If it is equal to 5, then it will also be raised. Then we have the other principles, like if it is followed by zeros and if the number is odd, then again it is raised. So these are all about rounding of digits. We have gone through, then we have gone through the significant numbers, and then previously errors. Now students, we will talk about our instruments. We will talk about our instruments. We have the instrument called the vernier caliper, and then we have the instrument called the screw gauge. So we will study about the vernier caliper. So, vernier caliper, if you see in the lab, this is the first experiment in class 11 which we gone through to measure the length of a wire, or to measure basically the thickness. We use it. So, vernier caliper seems to be like a scale. It seems to be like a scale. This instrument seems to be appear to be like a scale to us. Like, how is the scale? Similarly, this vernier caliper is, but vernier caliper, how is it different from a scale? When we have to find the various least thickness in case, like if we have a scale and if we have to measure it thickness, in the scale, if we have to measure it thickness, so if we have a scale and if we have to measure it thickness, so to measure it thickness, what do we use? We use vernier caliper. In To measure the thickness of this scale, we use the vernier caliper. So vernier caliper has again one is a main scale in vernier caliper. We have the main scale in the vernier caliper, and then we have the vernier scale. So then it is the main scale, and then we have the vernier scale in the vernier caliper. So students, so vernier caliper is a device used for accurate measurement. There are two scales in the vector calipers. In the vernier caliper, we have the vernier scale, main scale, and the main scale is fixed, and we have, whereas the vernier scale is movable. So we have four types of devices in a vernier scale. We have main scale, vernier scale, movable jaws. These are the jaws in the vernier scale which can be moved. And we have the metallic strip. So this is the metallic strip. Now, main scale is the main scale which seems to be like a normal scale. So which can measure the length of any wire, length of any instrument. So that this is the main scale, where you can see it is similar very much to a scale where we have the readings from 0 to 10. So here the readings are coming from 0 to 10. Now we have the vernier scale. In the vernier scale, this is the vernier scale where the readings are very much smaller. Because we have to go precisely in the vernier scale. We have to measure the values to a precise level. So we have this vernier scale. Now, movable jaws, these are the jaws A, B and C and D. So we can measure from here also and from here also. So from here also we can measure the instrument thickness, and from A and B also we can measure the instrument thickness. And this is the metallic strip which can be moved.